So piecewise functions. So typically we have a singular function that expresses what's happening across the full domain or besides restrictions. So in other words, for instance, I can have the function x plus 7. Let's not make it 7. Let's make it negative 7. And so that function looks like this. It crosses the y-axis right there and looks like this. Okay? So f of x equals x minus 7 is this function here. But what if I had a second function, for instance, f of, let's make it a different color, and let's go yellow, f of x equals negative x plus 2. And so that function looks like this. And so that's f of x equals negative x plus 2. So there are two functions on this graph, on this Cartesian coordinate system, making a graph of this green and this yellow function. But so what is a piecewise function? A piecewise function is where across the domain, so from this x value all the way over to this x value, or more specifically from infinity to negative infinity to infinity. Well, it doesn't even have to be that, but you can think of it as across all of the x's. Okay, I might have more than one function, but it's still a function. So these two individually are functions, but if I tried to group them together and think of them in aggregate all together as a function, it wouldn't work because the pair of functions do not pass the vertical line test. So we can do things to make a group of functions into functions. For instance, I can do the following. I can say that I care to follow the green function until I get to x equals 2. So the green function would be f of x is equal to, and it's going to be equal to x minus 7 for x less than 2. So for x less than 2, I would end up having the function that looks like this. And because it doesn't include the value of 2, I have an open circle right there at x equals 2 on that function, because it does not include the number 2. It's only the numbers less than 2. And then for the other part of my piecewise function, I would have negative x plus 2 for x greater than or equal to 2. And so I would only include those values that are from here all the way down to there. And it doesn't include all of that stuff. And it would include a solid circle here because it does include the number 2 as that part of the function. And so this is a function. It still passes the vertical line test no matter where I draw it, even if I draw it right here through those 2 points, because there's a point here but there's not a point there. And so it passes the vertical line test, and so I can call this thing a function. We don't always have to use 2 lines though. We can use any types of functions, and there can be more than 2. There can be multiple functions. And so for instance, if my function I want to define will equal all these functions, let's say x plus 1 for x less than 0. And so x plus 1 for values less than 0 looks like this. Open circle at 0, and all the numbers less than x equals 0 will follow the function x plus 1. Let's grab a different one. let's say it's going to be negative x minus 3 for those values greater than 3. And so negative x minus 3 looks like this. There's a point here. It has a negative slope of 1. So it looks something like this. But it only goes from x greater than 3. So I have an open circle here, and I actually have these lines, or excuse me, these points, not these guys up there. So that in and of itself is a function. It just has a missing group of x's that are not accounted for. So you could have one that looks exactly like that. And they could actually have equals signs here and here if you wanted to, or if you were given that. But let's go ahead and do a little bit more crazy stuff. Let's put x squared for those values for x that are less than or equal to 3, but greater than or equal to 0. So that means from here over to here, including 0 and 3, it looks like the parabola x squared. And the parabola x squared looks like this. There's a point at 0, 0, a point at 1, 1, a point at 2, 4, and at 3 it equals 9. So it's all the way up here, and that's where we stop. So my portion of this graph, that doesn't look very good, looks like this. Oh, it doesn't go on forever, sorry. It just stops there, comes down on this curve, and stops there. And so that's a piecewise function. You can make any of these functions anything you want them to be and separate them by little segments of x. So kind of a way to look at it is one function goes from here to the left, one function goes from here to the right, and the other function goes on in between those two values. And if you had 5 segments, you'd have 3 segments in between, and one segment shooting all the way to the left, and one segment shooting all the way to the right. When I say segment, I don't mean like segments of a line. I mean section of the domain, or a segment of the domain. So that's piecewise functions. You can have absolute value functions in there. You can have all kinds of polynomial functions. You can have, which includes lines. You can have square root functions or root functions of all sorts. Okay, so hopefully that's helpful. Typically you'll have questions that I'll ask you to graph or pick what the graph looks like for a certain value of x, and it's pretty straightforward, but hopefully we can go over it in lab or in class if you need to. Thanks, take care.